Welcome, my friends. Today, we are going over your review for your force test. So we will be taking a test on forces next Thursday. So now we're going to go through our review for that test so that you're all prepped and ready to go. So we're going to do this on page 15 of your science notebook. That should be your next available page. And I'd like you to please open up your core tools packet to page H2. So the H pages are all of our proficiency scales for your core tools packet. Your core tools packet is the one that looks like that. So if you want to pull that guy out and flip it open to page H2, you will find a page there that looks like this, where it has the forces proficiency scale. So the proficiency scale has everything on it that we need to know for your force test. We're going to start down at level 2 with the simple content, and we'll work through all these things, making sure that we know how to do them, and then we'll go to level 3 and then level 4. So starting at level 2, a few things that we should be able to do. You should be able to accurately use vocabulary such as mass, force, acceleration, net force, and vector. So the first of those three, mass, force, and acceleration, are in your physics everything sheet. The test will be open for your physics everything sheet. You can use your physics everything sheet on the test. So those should be good to go, and they should sound very familiar to you. Net force and vector we have also talked about, but just in case, because they're not quite as clear, net force is the total of all forces, or the sum of forces. If we're trying to figure out the net force, here is me, Mr. Williams. I'm standing on the ground. There's the ground. And I'm representing myself with a red dot. I have two forces on me. I have a force down, which is the force of gravity. And then I have a force up, which is the force of the floor or the force of the ground, pushing me back up and stopping me from falling to the center of the earth. I can also call that the normal force because it's pushing at a perpendicular angle, a 90-degree angle up. So because I have a force down and a force up, and they're both the same amount, I am not accelerating in any direction. I'm not accelerating upwards. I'm not accelerating downwards, nor am I accelerating side to side. So I have a net force of 0. The sum of all my forces, when I add them together, gives me no overall force, meaning no overall acceleration. So that's a net force, a total of all my forces together. Then we also have the idea of a vector. A vector is a quantity that has magnitude and direction. So magnitude is how big the number is, and direction is which way it's going. So here are two force vectors. I have a 10 Newton vector going to the right, or in the positive direction. And then I have a 3 Newton vector going down in the negative direction. So that 3 Newton vector could be a weight, a force of gravity. That 10 Newton vector could be a push that's being applied to something. Both of those have direction and magnitude, so they are vectors. All right, so that is the first piece. We can accurately use that vocabulary. Good job. The next piece is you have to be able to take a word problem and dissect it by identifying your needs and givens. We've been calling them the wants and givens sometimes, selecting your correct equation, plugging in your numbers and units, and then solving correctly. So we've done a lot of practice on that in chapter 8, in chapters 4 and 5, in your force and work practice problems, in your force, work, and simple machines practice problems. So you should have lots of examples of that. But that means there's 4 steps, 4 parts to every word problem that involves a calculation or math. You want to start with your needs and givens, or your wants and givens, whatever you want to call that is fine. Then you're going to give an equation. An equation, for example, would be F equals MA. That's using variables only, no numbers at that point. Then you can plug in your numbers and units. And then finally, you multiply or divide and solve. Okay. So that is that one. We're good to go there. And then finally, the third simple thing is to calculate the weight force for an object. So when calculating weight, let's do an example of that. Let's choose my favorite object, So we're going to find the weight in newtons of Mr. Williams. And today I have a mass of 72 kilograms. So my total body mass is 72 kilograms. I'm going to go through my 4-step process. Step number 1 is putting in my needs and givens. So I need my weight. And I know that weight is a force due to gravity. So I'm always, when I'm solving for weight, going to solve for a force of gravity. I'm given a mass, and the mass that I was given was 72 kilograms. And then I know that I'm on the planet Earth. And because I'm on the planet Earth, the thing that pushes me down, that gives me weight, is the acceleration due to gravity. And that's always going to be 9.8 meters per second squared. All right. So now that I have my needs and my givens, I will look for an equation that has all of my values in it, a force, a mass, and an acceleration. I look on my physics everything sheet under the equations, looking for an F, an M, and an A, and I find one under force that F equals ma. Now I can plug in my values. So I have a force is what I'm solving for, the force of gravity. I can plug in my mass, and I can plug in my acceleration. So I'm going to take my acceleration value and plug it in where I had acceleration. I'm going to take my mass value, which was 72 kilograms, and plug it in where I had my mass, my M. And then finally, I can multiply those things through and solve. So I take out my calculator, boop, 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 and I plug in for 705.6 newtons. So my total weight in newtons is going to be 705.6. When I say that out loud, it sounds a little bit like a robot. I don't think that I would give my weight to the decimal point. So there's a few options. If I was actually saying like my weight out loud, I could say I weigh 158 pounds. That's a true statement. That's pretty specific. So if I was going to round it to the ones place, I could say that would be 706 newtons. If I was being a little bit more round and I was just rounding it to the nearest 10, instead of 158 pounds, I might say I'm 160 pounds. That would be a reasonable rounding. So to my tens place, 5.6 would round up. So that would be 710 newtons. Or since it's so close to the 100, 705, I might choose to round to my nearest 100, and that would be 700 newtons. In chemistry, you'll want to be more precise with significant figures. In physics, we just want to give an answer that makes logical sense and sounds like a valid number. So in this case, I would accept either 706 or 710 or 700, depending on which value you wanted to round to. If I had to take a preference, I'd probably go 710 because that would be the number of significant figures. There is 2 digits in this number, 72, and there are 2 digits in 9.8. So I feel comfortable going to 2 digits, 71, and then putting the 0 at the end. So there you go. So that is how we find the weight force for an object. We're good with level 2. Let's move in to level 3. For level 3, this is the target that we'd like everybody to get to. This is going to be, I can analyze data to support Newton's second law of motion. And Newton's second law of motion states that force equals mass times acceleration. So we're going to use a few different equations that relate to Newton's laws as possible questions for your target content, for your level 3 questions. Level 3 for our test could incorporate any of these equations. The first one, obviously, is force equals mass times acceleration. You might be asked to solve for acceleration. You might be asked to solve for mass. You might try to solve for force. You could also solve for work equals force times distance. We've done that with simple machines, where setting the work on both sides of the simple machine equal to each other allows you to do the work on one side equals the work on other side, or the force times the distance equals the force times the distance. And then we can solve for mechanical advantage in a simple machine in 2 different ways, by comparing the force on either side of the simple machine, or by comparing the ideal mechanical advantage, the distance traveled on either side of the simple machine. So either one works, real mechanical or ideal. You should be able to calculate both. Let's do a little sample problem for level 3. We will do a force of 50 newtons. So I'm going to create a collision. I'm going to have a person sitting in a chair, like this rolly chair that I'm sitting in. And then coming from behind, I'm going to have a podium come in and hit me in the back. So this is going to be a tough one to show by myself, but imagine there's a rolling podium coming from over here. It gets pushed and it comes in and whacks me from behind. When it hits me from behind, the podium will stop. And because it just hit me, I will move forwards a little bit. So we'll pretend that we had that collision. There's our scenario. When they collide, there is a force of 50 newtons. The podium has a mass of 20 kilograms and it starts moving. It starts in the moving process. And then the person and the chair has a mass of 80 kilograms and starts from rest. So the first question, how much does the person accelerate? All right, let's start there. So because I'm looking at the person, I will focus on the person specifically. It's asking how much the person accelerates. And so I want to solve, my want is going to be acceleration. Things that are given to me. About the collision, I know that there's a force of 50 newtons. So my force is going to be 50 newtons when they collide. And then I have two masses. I have the mass of the podium and the mass of the person. When I'm looking at these, I'm going to pay more attention to the object that I'm solving for. In this case, I'm solving for the person, so I'm going to use the mass of the person. So my mass is going to be 80 kilograms. Now I'm going to find an equation that has acceleration, force, and mass. Check my physics everything sheet. And I find the equation force equals mass times acceleration. Now I can plug in my values. Force was 50 newtons. So I'm actually not going to put units on that. Equals the mass, which was 80 kilograms, times the acceleration, which is what I'm solving for. To get acceleration by itself, since we're multiplying, I need to divide both sides by 80. That will allow me to convert that to 1, which effectively gets rid of it. And it gives me an acceleration of 5/8 of a meter per second, which when I divide it, gives me 0.625, which I'll round to 0.6 meters per second squared. First time I did that, I forgot the squared in my unit. It should be meters per second or meters per second squared. So my acceleration for the person would be 0.6 meters per second squared. So that's how much the person will jolt forwards by in that collision. The next question is how much does the podium decelerate or slow down? So now, instead of looking at the person, I'm looking at the podium. Once again, I'm going to set up with my needs and my givens. My need in this case is deceleration. Deceleration is just acceleration in a slowing manner. So it's the same as an acceleration. So my need is an acceleration, but it's a slowing down acceleration. So I call it a deceleration. My givens, it's the same collision. So the same force applies. Whatever the podium hits the person in, the person hits the podium equal and opposite, because every force has an equal and opposite force. So my given is a force of 50 newtons. And then it's asking about the podium this time. So I know that there's a mass on the podium and that mass was 20 kilograms. So since it's asking about the podium, I'm going to focus on the podium's mass, 20 kilograms. Now I can choose an equation again, one that has force, mass, and acceleration. F equals ma. Plug in my values. 50 newtons equals the mass of 20 kilograms times A. Get A by itself. I'll divide both sides by 20 kilograms. 20. That allows me to cancel there. 50 divided by 20 gives me 2.5 meters per second squared as my acceleration. So I'm going to have a deceleration of 2.5 meters per second squared. If you prefer, because this is slowing down, we could also call it a negative 2.5 meters per second squared of acceleration. But since the question was asking for a deceleration, it already knows that it's slowing down. So I don't have to include that negative sign because I already know it's slowing based on the deceleration question. All right, let's do one more. So last one, I have a system here that has two ramps, ramp A and ramp B. Both of them are taking the same load, the same ball, and we're pushing it up to a total height of 5 meters. A is steeper and B is more gentle. Both ramps have no friction. Which one requires more work? Pause the video, think about your answer. Welcome back. Glad you unpaused. So we're looking for which ramp has more work. In this case, work is equal to force times distance, and work is also equal to the change of potential energy. Remember, we did our pencil up work to potential energy. So since work is equal to the change of potential energy, and in both cases, I'm taking the same load up to the same height, I'm accomplishing the same thing, I do the same amount of work. Work A is equal to work B because I'm going to the same height, and thus they have the same potential energy and the same work. All right, question number 2, about the same two. Which one requires more force? Which ramp, if I'm pushing the ball up, requires more force? Pause the video and think. Welcome back. All right, for more force, A requires more force because A is steeper. That means I have to push more on the underside of the ball, which means I am applying more force against gravity. I have to overcome more force of gravity, which means it requires more force pushing up the ramp. Another way you could think of this is we already established that the work is the same. So my work for both boxes has to stay the same. If I have a longer distance that I'm pushing, which would be true in ramp B, as my distance goes up here, my force has to go down. So the longer the ramp is, the less force is required. The more gentle the ramp, the less force, which means A has to have more force than B because it's steeper. All right, so that is level 3, our target. And then finally, for level 4, there's lots of ways we could address level 4. We'll address some of it in our project. There will also be a level 4 question on the test. That level 4 question on the test will have a huge data table looking at real data with forces and masses and accelerations with some collisions. And you'll have to make some conclusions looking at that complex data table. So it'll ask you to look at the data, look for some patterns, try to figure out what you can, and then relate it to Newton's second law and see if you can come up with something good. All right, best of luck on that test. You'll do great with it. If you need to go back and review chapter 4 and 5, chapter 8, or the force, work, and simple machines practice problems, those would all be great things to review. Have a lovely rest of your day. Bye, friends.